How's everyone doing today? If you can't hear me at any point, let me know. I think everything's set up. Yeah, as he mentioned, my name's Houssein Djirdeh. I work as a developer advocate on the web team at Google, and my main focuses are speed, performance, and frameworks. And my talk today will be about progressive React, or if you like an alternate title, how to build your React app so more people can use it. Now, performance advocates, including myself, we tend to give a lot of advice to developers on how they should build their app and how they should make it as small and as fast as possible. Sometimes it can feel like our message comes across like this. So what I'm going to be doing for the rest of this talk is I'm going to take a leaf out of the Pandas book and just give you all 100 reasons why you should stop using React. No, I'm joking. I'm not going to do that. No, what I'm actually going to do is I'm going to talk about how you can continue to build the React apps that you're working on, but to consider adding a number of enhancements to it. And again, you want to add these enhancements so more people can use it. But what do we mean by more people? How do we measure that stat? Is it useful to even measure that? To help us answer this question, let's take a look at Create React App. Now, Create React App is by far the easiest way to get started with a React application with a working build system and toolchain. If we take a look at what's provided right out of the gate, we have the React library that lets us build what we need to build in terms of components. We have a renderer that allows us to render what we want to build to the DOM. And then we have that initial application code, that first component that gets scaffolded for us. And all in all, we're looking at about 36 kilobytes minified and compressed. Now, these numbers are for version 16.8.6, in case you're wondering. To sort of understand what this number means in terms of loading performance, we can take a look at Web Page Test. Now, Web Page Test is a tool that allows you to test how fast a site loads on a particular device that's hosted on a device farm somewhere. And you can do this while changing a number of different settings, like network type, for example. If we run the Hello World app provided by Create React App on a Moto G4 mobile phone on 3 different connection types, we can see that the time it takes for the application to finish loading can vary quite a bit, from 2 seconds all the way to a little over 4 seconds. Now, although these numbers might seem interesting, it's not entirely useful until you really know what device and what network connections your users have. And that brings me to the next point. There's no such thing as a slow site. And you can quote me on that. But no, in all seriousness, this makes no sense. I think we've all experienced a slow site at some point. But I think the one thing that I want to address here is that your definition of slow and my definition of slow can vary quite a bit from our users depending on what devices and connections they have. For example, if you happen to be testing your app on a desktop machine with a healthy cable connection, the speed that it loads will be completely different than if the user was using a weaker device like a Moto G4 and has a slower connection. Now, in terms of what React DOM and what React provides right out of the gate, in terms of initial bundle size, the React team have been looking to trying to improve and minimize the bundle that's provided by React DOM. And they've named these efforts React Fire. And they're trying to do a lot of things to improve the library itself, but one thing they're trying to do is simplify the event system, see which parts they can remove, and which polyfills they can remove that aren't needed for newer browsers. They've put this on hold for now, and they have a separate PR I think they've called React Flare, where they're trying to improve the event system, but they plan on coming back to this to see if they can cut down its size as much as possible. And that's exciting, because it's always nice to know that we're starting with a good footprint of a small app, as small as it needs to be. So one thing that I've been pondering for quite some time is, what's the current state of speed? Like, is there a way to accurately measure how well a majority of sites that use a particular framework or tool are performing? Do we even find that information useful? I try to see if I can answer this question by looking at HTTP Archive. Now, for those of you who haven't heard of HTTP Archive, it's an open source attempt to track how the web is built. And it does this by crawling over 4 million URLs every month, passing them through web page tests, and then storing key information about them, like the amount of network requests sent, the size of payloads, so forth and so on. HTTP Archive a few months ago integrated with Wappalizer. And now Wappalizer is another third-party library that allows you to detect which tools and which libraries are being used in a page. And it does this through a number of mechanisms and heuristics. I thought it would be interesting to combine the two and see what would happen if we decided to measure how well React sites globally are performing. So I queried over 100,000 origins that use React, and I noticed for mobile, the median first paint was about 4.7 seconds. And first paint is the time it takes for anything to render on the app. The median time to interactive was over 20 seconds. And time to interactive is a synthetic lab metric that defines when a JavaScript thread settles and your user can interact with your application. Now, although alarming as these numbers might seem, we need to take them with a grain of salt. You see, there are a million reasons why a site might be slow. And it's not fair to say if they're only using React and that might be the cause. This is the perfect example of correlation does not mean causation. However, I still found these numbers pretty interesting. One thing we can agree upon, though, is that we are shipping way more JavaScript than we've ever done before. If we take a look at HTTP Archive again, we can see that as of 2011, the median amount of JavaScript that we shipped to mobile web pages was slightly over 50 kilobytes. And now we're looking at about 360. And that's a huge jump. So what can we do? What should we be doing with our sites, our React apps, and so forth, to minimize the amount of code that we're sending to users, as well as make it as performant as possible? The very first thing we should think of doing is profiling and analyzing. You see, there's no point in trying to prematurely optimize your site if you don't know how well it performs. On a component level, you can actually do this by opening up Chrome DevTools. If you open up Chrome DevTools, go to the performance panel, and then go to the user timing, you can see how long it takes for components to render. And this is possible because React takes advantage of the browser's user timing API. And it marks and measures when components start rendering and when they end rendering. This lets you dive in and see which components are taking longer to render than they should, and allow you to focus your time in improving their performance. Now, React took this a step further. React DOM 16.5 introduced a profiler tab to the DevTools, React DevTools Chrome extension. And the way that tab actually works, it's similar to the performance tab in the sense that it allows you to record interactions on a page. Here you can see a very simple example of an app that I built that allows the user to click a button, and then after a certain period of time, it just fetches a list of top trending repos on GitHub. Now, whenever you decide to record an interaction like that and you stop, you can actually see a pretty nice flame graph that shows you how long your components are rendering, and you can switch between different commits that allow you to see how different states of your application or where DOM nodes are being added, removed, or replaced, and start figuring out where exactly your app might be staggering. You can also see metadata like total render numbers, state, props, and so forth. If you are interested in trying to improve and see how long your components are taking to render, I'd highly suggest just opening up or installing React DevTools and then just opening up the Profiler tab. Now, let's say you use Chrome DevTools or the Profiler tab in React DevTools, or in your own way, you found out that a lot of your components are rendering more than once or more than they should, or rendering too long. The first thing you should think about doing is trying to minimize unnecessary re-renders. You can do this with a number of different ways. By overriding should component update, by using pure component and class components, or using React.memo on functional components, by using the useMemo hook, and virtualizing long lists with a library like React Window, for example. This link will actually take you to the introduction blog post about React Profiler built by the author, Brian Vaughn, and he has a very nice article about how exactly you can use it. He also links to a YouTube video of how he shows you he actually uses the profiler to identify performance bottlenecks in an application, and then you can also see how he does it and how he improves the final app speed. Now, aside from component re-rendering, we can also take a look at higher level concerns. And when I say high level concerns, I mean the amount of code that we're shipping. One tool that we can use to measure this is something called Lighthouse. Now, Lighthouse is an open source tool built by the Google Chrome team. And you can use it in a number of different ways. You can use its Node CLI, you can use its Chrome extension, or my preference, you can just open up Chrome DevTools, go to the audits panel, and then just decide what audits you'd like to test, what throttling settings you want, and you can run audits right there and then. It takes a little time for Lighthouse to gather information about your site, and then it shows you a report on how well you're doing. And you can see in terms of performance, in terms of SEO, in terms of accessibility, as well as other fields. If you're interested in improving speed, you'd want to focus on the performance section. Now, there are a number of audits that can get flagged where you can sort of identify that you might be sending too much JavaScript. One of them could be eliminate render blocking resources. Another could be that your JavaScript boot up time is just too high. And another one can tell you that you're shipping way too many large network payloads. If you're using Lighthouse to identify and figure out whether you're shipping too much JavaScript or you're doing it in your own way, the first thing that I would suggest doing is to code split. Now, code splitting is a term that many of us here might have already heard about. And the idea behind code splitting is to only ship to your users what they need and allow them to get parts of the code as they make their way throughout the application. A very simple way to start code splitting is by using dynamic imports. Now, dynamic imports are supported in newer browsers like Chrome and Safari, and they're already supported in a number of bundlers like Rollup, Parcel, and Webpack. And they look like a function call, but they actually allow you to import a module asynchronously, where you can then chain a promise or use async await to do what you need to do after it gets fetched. In this very simple contrived example, you can see that I'm importing the sort by method from Lodash, and only when that gets fetched, after the user clicks the button, 3 numbers get sorted. Now, the reason why I say this is a very contrived example is because if you really wanted to sort 3 numbers, you can just use array prototype sort or write a small function for yourself. But I hope this demonstrates what I mean by dynamic imports. The thing about fetching code and fetching components and fetching modules asynchronously is you'd want to make sure that your users have some sort of indication that something's happening if it takes a certain period of time. So to make the process of using dynamic imports easier and to account for this, you can use React.lazy. The way lazy works is it's a wrapper around dynamic imports, and it allows you to define components that take advantage of asynchronously fetching their code. You can also use the suspense component with .lazy. And the way suspense works is it allows you to define a fallback component which will render while the original component is being fetched. Now, the thing about code splitting and the thing about using suspense and .lazy is that a lot of people might not be sure about where exactly they can begin to code split in their React application. The easiest way to start is to do it at the route level. And if you look at the React docs, it actually shows you how you can use suspense and lazy with React Router. And you can still use the suspense component as a parent component, and then you can pass in your lazy load component into your route like any other component. Only after you start splitting at the route level, if you still feel like you can make some more wins, then you can try to figure out where else you can split. Maybe on certain user interactions, like clicking a button, or on scroll. But that usually takes a little more time. Now, another thing that we're starting to see a lot more happen in the Chrome team and in the developer community is the concept of progressive rendering. Now, progressive rendering is code splitting, but it takes it a step further. And it takes advantage of server-rendered markups. Here's a visualization by Jason Miller on my team, and we both gave a talk at Google I/O about progressive rendering. And the idea behind progressive rendering is if you have a typical server-side rendered application on the left side, with a typical idea of that it gets hydrated at once the JavaScript bundle loads, you can instead think of partial or progressive hydration as only loading the JavaScript for different parts of the code when they actually are needed. The reason why this is pretty exciting is that if you combine the best of server-side rendering with code splitting, maybe you don't need to show loading indicators to your user, and maybe they can actually see all the content immediately, but only when they begin interacting with the application, it becomes more alive. So to switch gears for a bit and talk about caching things worth caching. When I say cache here, I'm talking about a service worker cache. Service workers are scripts that run in the background of your browser when you view a web page. And the idea behind using a service worker is that it allows you to cache important files so that when your user makes a repeat visit, those files can be served from the service worker rather than having the browser make the trip to the network. Although you can write your own service worker file and create your own logic, there are libraries out there like Workbox that can make it easier. And the idea behind Workbox is that regardless of what build system or framework you're using, you can have a service worker up and running and built on the fly. To sort of demonstrate how much of a difference a service worker can make, you can see that it can make a bit of a difference when you're using a slow connection and a weaker device. So service workers were merged in to create React apps some time ago, and they were enabled by default. And I think this is about a year ago, or no, back in 2017 actually, there was an issue thread started with a question, why exactly were service workers merged? And I think a lot of people realized there is benefit to making sure anybody that uses a Create React app automatically got the benefit of using a service worker without actually doing any additional work. But some people had some concerns, and they were concerned about how people who weren't familiar with how the service worker cache works might be confused with what's going on behind the scenes. Are the files that I'm seeing being served by the service worker? Are they being served by the latest version of the code? It can be tricky if you don't know exactly what you're doing. So the overwhelming consensus was to not enable it by default, but to just have it be opt-in. The good news is if you actually want to opt into using service workers, you only need to open index.js in your Create React app directory and remove 2 characters of code. And that's essentially it. Now, with Create React app version 3, quite a few people on my team were trying to push for having a config file enabled. Because you see, although it's very nice to have an opt-in service worker that works right out of the gate, maybe you want to change a few settings about it. Maybe you want to make sure some resources are served from the cache first, or maybe from the network first. And it might be weird to only think of ejecting to be able to do that. Although this wasn't merged into Create React app version 3, I think a future iteration will have a Workbox config JS capability, which allows you to define a single JSON file with a few settings to control the service worker without having you actually dive in and write the code yourself. And now to switch gears one more time and talk about CSS and JavaScript. Now, CSS and JavaScript has been something that's been in the React community for quite some time, as well as in other communities. And the idea behind CSS and JavaScript libraries is it allows you to build your CSS code within your JavaScript components. And a lot of people felt that it was a lot more fluid. It felt more encapsulated, it felt more real. You didn't have to worry about the cascade as much. And although there's varying opinions about whether people like to use CSS and JavaScript libraries, like styled components, and Glamour, and Motion, and so forth, I noticed that it actually makes the process sometimes feel better. However, if you're not entirely careful, you might not realize that having CSS and JavaScript means that your bundle will keep growing. And then if you're not concerned about extracting that CSS, your users will only see unstyled content until the bundle finishes loading. So one thing you can do there is you can make sure to try and extract your critical styles. If you're server-side rendering, you can inject them so your users can see them initially with the markup, and they don't see that flash of unstyled content. If you don't want to go through the process of actually building an entire server for this is where pre-rendering comes in. Now, pre-rendering is the concept of using a headless browser like Chrome Puppeteer or any other similar version, and it allows you to crawl routes in your application and build HTML files for each route at build time. And now you don't have to worry about making sure they get served from the server at runtime. You can have them built early on, ahead of time, and they already have that capability of styles injected. To sort of demonstrate what I mean by making sure that your styles are being injected into your markup, you can see that, especially on weaker devices and network connections, that difference, that jarring difference of flash of unstyled content can be quite extreme. Now, this is a Preact app, not React, but the idea still remains. So one of the last things I do want to talk about is if you're thinking about performance and you're thinking about improving the capability and the speed of your site, it's very important to try and keep an eye on how your application is progressing. And the reason why I say this is one thing we're noticing quite often in the Chrome team is a lot of teams that actually improve the speed of their site end up regressing. Because it's very easy to focus on feature deadlines and scope creep and so forth and not think about how exactly your site's performing until it's too late. There are tools out there that can actually help you do this. Webpack Bundle Analyzer is one that I like to use, and it gives you a very nice heat map or tree map visualization of your entire bundle. Size plugin is a tool built by Jason on my team that allows you to see changes in your bundle size with every build. And now I want to talk about things we're trying to do and that I'm trying to focus on in the past few months. And one thing that we've actually launched in Chrome is something called web.dev, and we're trying to revamp our entire documentation site. One thing that we noticed is we have a lot of generalized advice and a lot of high-level advice that you can apply and anybody can actually read and learn, but not things that are very specific to frameworks and to specific developers. So web.dev actually allows you to run a trace on your site. It integrates with Lighthouse. It'll tell you how your site's failing or what it can improve on, and then we'll actually link you relevant guides useful for your site. I've been trying to make sure that we actually have guides that help you improve React sites in the performance sense. And not just React, we're going to be moving this on to other frameworks as well. Something else I've been passionate about is the new feature to Lighthouse called Lighthouse Stack Packs. Now, the thing about Lighthouse, again, is that it provides very generalized advice. And this is a good thing because anybody using Lighthouse will get high-level suggestions on what they can be improving and what they can be changing. But one thing we're trying to do with Stack Packs is maybe provide additional advice depending on what tools your site is using. For example, let's say we detect that your site is using React. What if we could tell you, for like the avoid enormous network payloads, instead of just giving you a high-level advice, what if we could tell you something like consider splitting your bundle with React all lazy and ensure a minified production model, something specific to the user. Now, Stack Packs did roll out a few months ago with version 5 of Lighthouse, and we have WordPress support. But the next few quarters, I'm hoping to have React support, as well as other tools and frameworks. The very last thing I do want to talk about is the concept of developer experience versus user experience. So one thing that I see quite often in Twitter and a lot of other channels of communication is that there still seems to be this concept that we can't get both. That we have to either give up developer experience for a better user experience, or we have to actually harm our user experience for a better developer experience. And what I'm trying to do is make sure that everybody can get the best of both worlds. The idea as being an advocate is we win if the tools that you use have good guardrails, good defaults, and always keep you on the narrow path of performance. If the tools that everybody uses always keeps them in check, I wouldn't have to come on stage and do my job. And that's something that we hope we'll actually see in the future. Not the part of me not having my job, I mean the part of people having tools that do them for them. I hope you enjoyed this talk as much as I enjoyed giving it. Thank you. My name's Houssein. Happy to take questions anytime today. I'll be around.